Alright. So now we have done with moment of inertia. Now it's time to start torques. Right. Torque here from we will try to understand the motion of rigid bodies. Right. First try to understand what is torque. As it is mentioned, look here, torque is the rotational effect of a force given by tau is equal to R cross F. Why I am saying rotational effect of a force? A very simple example of that is when you open your door, you have to push the door, right? When you are opening the door, you have to push or pull the door. And you can always see that you have to apply the force at the door handle which is away from the axis of rotation, right? Have you ever seen a door? What commonly door is? If this is a door and this is the axis of rotation.
Near means very far from the axis.
Yes. Have you ever seen a door with a handle here?
No, sir.
No. No. Although you have to apply force in this handle and it is very easy to open the door if you apply force here. Right? But the same force if you apply here, you will find it is difficult to rotate that door. So definitely depends on the point of application of the force now. Right? That is why this R came here. So torque is the rotational effect of a force given by R cross F. Right? So if it is a body and you are applying a force somewhere here you are applying a force, then torque about any point, suppose this point is O and I have hinged the body here at point O. So about this point O, how do I find the torque of this force? Very easy. If you join this point O with this point and then this is the R vector or position vector, then you can see R cross F is the torque about this point O. Right? Can you tell me the direction of this torque?
Sir, we do right hand rule.
It is towards my nose.
Yes, it is coming towards you. If it is XY plane, then it is definitely along Z axis.
So it's dot. It's dot.
Yes.
Yes, a dot.
Now, one thing you should always understand, if I drop a perpendicular from the point O to the line of action of this force, this line, if you straightly elongate this line of this force F, it is called line of action of this force F. If you drop a perpendicular from O to that line of action of the force F, this distance d is known as the arm of the force, or you can simply say that why I am saying this d is important. If you calculate this angle theta, can you say that R cross F is nothing but
df is the torque.
Yes, R cross F, the magnitude is nothing but mod R mod F sine theta.
That is df.
Yes or no? Now what is R sine theta? Can you see R sine theta is nothing but D?
Yes, sir.
So torque has a magnitude which is nothing but the force multiplied with perpendicular distance from the point where you need the torque to the line of application of the force.
Yes, sir.
All right. So this is a easy way to calculate the torque. Now, another way to understand the direction of the torque is simply, always you can do a cross product. If you are comfortable in that, no problem. Otherwise, sometimes torque, if you do cross product always, it may be a time taking. But if you understand it like this, that suppose there is a body, right, and you have hinged the body here. So if you apply a force in this direction, upward force, in which direction the body will start rotating? about this
Sir,
point.
it will rotate in that
It's a
anti-clockwise
body.
circle on the plane. Anti-clockwise circle on
It
the
will
plane.
rotate anti-clockwise or not?
Sir, please repeat the question you asked.
I'm saying to find out, in order to find out the direction of the torque, you can always assume it like this. Forget about all the other forces. If you think about only one force F, and suppose the body is hinged here, for this upward force, if you apply a force on this body, where the body will move upward in this direction or clockwise direction? The body will rotate in anti-clockwise
Upward.
direction. Anti-clockwise direction.
It is hinged though.
Yes, it is hinged here, so the body will always assume it to be hinged. Even if it is not hinged, you can assume it to be hinged at this point O. If you have to calculate the torque about point O, here actually
Yes.
I am calculating torque about point O, so that is why I have assumed the O to be at hinge point.
Hmm.
Look now,
This
if
with
you
respect
curl
to
your if you curl your right hand fingers along this anti-clockwise direction, you will always find the direction of torque.
yes, yes.
sir.
Right, so that is another way where you can visualize not only torque but also the effect of torque, that in which direction the torque is rotating the body. Yes or no?
Sir, I have a question.
Yes,
So that is actually the same way we are doing right hand rule.
the same thing.
Sir, I have a question, sir.
Yes,
Sir,
বলো বলো শুনছি।
হ্যাঁ হ্যাঁ স্যার স্যার টর্কের ডিরেকশনটা কেন কোনো ইনফ্লুয়েন্স করে না? যেমন আমরা ধরুন দরজা খুলছি, তাহলে টর্কের জন্য তো দরজাটাকেও উপরে উঠে যাওয়া উচিত না?
No, this is rotational vectors. Rotational vectors have a direction that is perpendicular to this plane. R আর F এর perpendicular direction to rotational vector, na? But if you
Yeah.
think why,
That's okay. But what is
yes.
the effect of that? Means
Yes, the
why
effect of that
can't I
is
feel?
that if you are saying that torque is upward, right? In this particular case, the torque is upward. In which direction its omega is? Is omega in this plane or omega is also upward?
Omega is also upward, yes.
So look, torque and omega are also in the same direction. That is the angular acceleration also. If I say it is rotating in this direction, omega is increasing, then what is the direction of angular acceleration? Is it along on the plane or it is also perpendicular to the plane?
It's also perpendicular.
Yes. So all the vectors are perpendicular. That is why torque is perpendicular.
So what is the essence of the direction? Means suppose force is acting, means I can feel on which direction it is acting.
Force,
So
yes,
why can't
force
it
may
be-
be acting in any direction. Force can also act downward direction. So in that case, in which direction the body will rotate?
So that will rotate anti-clockwise only.
No, if the force is acting downward,
So then it will rotate clockwise.
clockwise. Yes, so the torque will also act along the same way.
Okay, sir.
Alright. So that is the torque, and I have written here that where R is the position vector of point of application of force F from the point about which we need to calculate the torque. Right? So this is the point. About this point I want to calculate the torque. So I will start my position vector from here, and the vector will end at the point where the force is acting. It can also be found by multiplying force with perpendicular distance from point about which we want to calculate torque to the line of application of the force.
Yes, sir.
Alright. Now we will understand few very important properties of torque. Right. Based on this property, we will study the rotational motion dynamics. First property, look, torque can be defined about an axis also. To find torque about an axis, we can find torque about any point on that axis and take the component of that torque along that axis. What do I mean by that? Let me just show you. Suppose it is a planar object. Right? This is a planar object. Now the object can rotate about this axis of rotation. It is the axis of rotation. Look, point O lies here, but the axis is this one. Suppose the axis is Z axis and the object lies in XY plane. Right?
So what is O, sir? You said?
O is the point of intersection of the axis with the body. Right? The axis of rotation passes through O actually. O is not the center of mass, not any spatial point. Any point you can say. XYZ axis. Now suppose I am applying a force here, right? Here a force can be applied in three different ways or two different ways. Suppose I have applied a force here and I have applied a force like this, or suppose in this direction. This force is F1 and this force is F2. F1 force lies in XY plane. F1 force lies in XY plane. But F2 force is perpendicular to XY plane.
Yes, sir. Yes, sir.
Right? F1 is in XY plane. But F2 is along Z axis. Both the forces are having the same R vector, yes or no?
Yes, they are having.
Both the forces are having the same R vector. Suppose this is the R vector. Let us first consider the torque of this force F1. For F1, if I say that I extend this line, right, and suppose the perpendicular distance from this point to this line is D, then what is the torque of F1? Can you tell me what is the torque of F1?
F1D, F1B,
F1
sorry, F1D.
1 second. Torque of
Sir, can you-
F1
So can you
about
please repeat the last two lines, sir?
I'm saying that can you see the force F1 that lies in XY plane?
Yes, it lies there.
We are trying to find out the torque of F1 and F2 about O.
F1D, F1D.
F1 into D. What is the direction? Look, if you are talking about torque, you have to always mention the direction.
Yes, sir, I am saying so it's along Z, positive Z.
It's K cap.
Yes, good. It is F1 into D K cap. For F2, what is torque?
So F2 it is, so please wait.
Sir, it's coming out of the plane of paper. It's F2D.
F2D. Is it F2D?
What is D? D is in the plane only.
Yes. What is perpendicular distance from O to
F to
F?
R.
R is only perpendicular
That
or
is,
not?
that is R. Oh, yes.
It is F2 into
Oh,
R.
oh, yes, it is.
Yes or no?
Sir,
Yes.
sir, can you
What are you
explain?
doing with the F1 0, F2 0? What is that?
Not 0, it is about O. Torque of F1 about
Okay,
O,
okay.
torque of F2 about O. Yes.
F2, that direction is, I'm saying, sir, that's grazing the plane.
Direction is perpendicular to R vector but on XY plane or not?
Yes, sir, it is on XY plane.
Yes.
Sir,
বলো
can you explain this figure? Sir, এই ফিগারটা আরেকবার explain করবেন?
There is a two-dimensional body, as you can see. I have given two forces on the body. One is along z axis, another is on the plane F1.
Okay, sir.
So what is torque of F1? It is F1 into d, as we have mentioned. D is the perpendicular distance from O to the extended line of F1. And that torque is along the z axis. And what is torque of F2? Torque of F2 is F2 into R, and that torque is perpendicular to F2 and R both, and definitely it is lying on xy plane,
Yes, sir.
Yes, sir.
right? Now if I ask you, what is the component of tau 1O about z axis?
0.
No,
Zero.
tau
Zero.
1O, 1O.
But tau 1, it is F1D only.
Yes.
F1D.
Full.
Yes.
Full.
So
Okay, sir.
component of tau 1O along z axis is F1D? Yes or no?
Yes, sir.
But what is component of tau 2O along z
Zero.
axis?
That would be zero. That stands for zero.
So if I ask you, for these two forces F1, F2, what is torque about point O? You should give me the answer F1D k cap plus F2D, F2 into R, whatever may be the direction of that. The answer
N
is
cap.
both. Addition of this tau 1O plus tau 2O will be your answer. But if I ask you what is the torque about the axis, what should be your answer?
So it should be F1D only along Z.
Yes, the torque about the z axis is only F1D.
So have you given 1, 0, comma Z that in the tau?
Tau, yes. 1 0 means torque of force 1 about O, and comma z means its component about z
Along Z, yes.
along z axis. So do you differentiate between these two concepts? One is torque about a point, another is torque about a axis.
About a point, the vector sum of tau 1 and tau 2.
Yes, but about axis, it is their components, their individual components about that axis. Now, if I ask you which is responsible to rotate the body, who is responsible to rotate the body? Torque about the point or torque about the axis?
So talk about the point.
Yes,
Axis.
is it torque about the point or torque about the axis? Let us try to understand it with the same example of the door. If you have a door and you try to open that door by the application of a force, now there is handle here, right?
No, sir, it should be along axis only.
Where do you apply a force? Suppose you are applying a force along this line. Will you be able to open that door? Yes or no?
Yes,
Yes.
we will.
But I apply the same force. I am applying the same force, but I am applying the force along this line. Will you be able to open that door now?
No, sir, not at all.
Not
That's
at
a
all.
no-no.
But both the forces will have a torque about any point. Suppose this point is O. Both the forces will have a torque about this point O. Yes or no?
Yes, sir, they will have.
Same magnitude. But if you find the direction of the component of those torques about this axis, then which force will have the component about this axis, F1 or F2?
F2.
1.
F1 will have a positive component
will have
about,
along axis, then
yes.
tau.
Yes.
F1 will have a component about this axis, means opposite or hote pare, if it can be upward or downward. But F2 will be always, if the torque about O of the force F2 will be perpendicular to this axis, so it will have no effect on the rotation of the body.
So it will not cause any sort of rotation.
Yes, it will not cause any sort of rotation.
Yes, sir, got it.
Have you understood this part clearly?
Yes, sir, I have got it.
Yes.
So
Sir,
if I
can we write it in one line in statement?
have written it there
Oh,
in property
it's
1, torque can be defined about an axis. To find the torque about axis, we can find torque about any point on that axis and take the component of the torque along the axis. Look here, I have proved this by taking the point O. But it is true even if you take the point, any point on this axis. You try
So
to
would that
prove
be
it.
convenient?
Yes. For example,
Because that becomes sin theta and it would always result in R
yes.
and D.
Look, for example, if you can visualize this thing, if I say this point is suppose O prime, what is the torque of this F2 about O prime? Will it be the same or different? Look,
Torque
if you
of F2 about O prime.
O prime, the distance between these two axes will remain the R only.
Okay.
Yes or no?
Yes, sir. Yes, sir.
Yes. So basically, it does not depend on which point you are taking. It can be also proved mathematically, but I'm not going into that proof. It's simple proof, very simple proof, but it's not needed.
Proof that both are same, too.
Yes. So any point you can take about that on that axis, you take torque about that point of all the forces, and then what you do, then you take the components of all those torques about that axis, and that components will only be responsible for the rotation.
Torque along the axis.
Yes, and that is the torque along the axis. খুব ভালো করে এটা বোঝো, because whenever you will do rotational question, there is a very common misconception that we mostly will take a torque about any point and axis will be the same in most of the questions, but there are some concepts where we need this concept that torque about an axis is important, not torque about a point.
So can you please wait for 2 minutes?
Yes, sure. Look, we have also covered the second point. Can I say, for any force parallel to the axis of rotation, the torque about that axis is 0. What was F2 here? Parallel
Yes, sir,
to
because
Z
it
axis.
will be perpendicular to R and
Yes,
F. So F
yes.
perpendicular means axis is perpendicular,
Good,
so not
good,
along
good.
axis.
Yes. That is the only reason. If it is perpendicular to F2, it will be perpendicular to the axis of rotation.
একটু অ্যাঙ্গেল থাকলেও একটু এফেক্ট থাকবে।
Yes. So it has no effect if it is perpendicular. If it is parallel to the axis.
See, is torque and couple the same thing?
No, we'll talk about couple.
So let me note this one.
Is it clear to everyone?
Yes, sir.
Okay.
Sir, please wait.
Yes.
Sir, understood.
Okay, alright. Can I erase this board?
Yes, sir. You can.
Alright. Now, move to the third point. All these properties, as I have told you, are very important. Third point says torque of couple forces are same about any point. What are couple forces? This is a very simple point and you can easily understand that suppose there is a rod and there are two forces applied on the rod, right? The forces are like here it is F and here it is F. Couple forces are the forces addition of those is 0. Couple forces means the net force is 0. So these two forces are known as couple force. The point of application of the forces are different, but the net force is 0. Suppose this point is A.
So these are called couple forces. So
Yes, these are called
point
couple
of application
forces.
are different.
Yes. Point of applications are different, but net force is what? How much? 0.
0.
And suppose this distance is x or this distance is say L, right? Now we can take any point, suppose on the space. Suppose this is the point. I want to find torque of these two forces about this point.
About this point.
Yes. Right. For that, I need this distance. Suppose it is x.
Yes, sir.
Can you tell me what is the torque of this upper force F?
So it is F into x plus L, and it will be directed into the plane of paper.
F into x plus L, yes.
And directed into the plane of paper. That's minus k.
F into L plus x, in which direction it is?
Minus k.
Minus k cap. Very good. And what is that force, torque of this force?
So that will be F into x, and that will be directed towards towards k. Yes, sir, towards k.
K cap. If you add these two, what you will get?
So it is minus FL. Towards
F is constant and L is also constant, yes or no? Does this L depend on the choice of your point P?
no, sir.
So it is independent of P, independent of X. That is why I have written that torque of couple forces are same about any point. Torque of couple forces are same about any point.
But can the point be on the body?
Any point means it is definitely. It can be the point B also. If you take point B, what is the torque of this force, lower force?
It will become very easy then. So it
Yes.
is just FL.
It is only FL. If you take point A also, what is the torque?
So it is also FL.
Also FL. So actually it is true for any good point on space. You will find the same torque about any point.
Yes, sir.
Right? Okay. So this was the third point. And now come to the last point. That tau is equal to I alpha. How I can say that tau is equal to I alpha? For example, there is a body which is hinged here and the axis of rotation is coming towards us, dot axis of rotation. Okay, I am seeing a top view.
So please repeat this, sir.
I am seeing a top view of a body, planar body,
Oh.
and this is the axis of rotation coming towards you. Okay. Now, if I say that due to a torque, the body is rotating with angular acceleration alpha. I need a relation between tau and alpha. I have to prove it actually.
So means this is a body and that point is my pivot point. So
Yes. This point is my pivot point.
that is rotating whole body.
Rotating with angular acceleration alpha above that pivot point.
Okay, sir.
You can take any small body dm mass here. This distance is r. Can you tell me what are the different forces acting on this body dm?
Different forces. So internal forces are there.
All the forces. You can understand the force by understanding the acceleration. Remember,
There is centripetal force.
there is centripetal force. What is the value of that centripetal force? If it has omega,
M omega square R.
Square. Bar omega square.
and another force, tangential force.
Oh, there is alpha, right? Oh,
R alpha. R alpha.
there will be one of them.
dm into r alpha, yes or no?
DM R alpha. Yes, sir. DM R alpha.
So if I ask you what is the torque of that forces about O,
Mm.
d tau.
It is only of tangential.
Yes, sir. It is only of tangential.
Yes.
That
This
is,
force will not give any torque. So
That
is
is
it only
R times DM R alpha. That is DM R square alpha towards my nose.
so if I integrate this, can I get the total torque?
Yes, sir. I will get.
So what is the total torque about this point O? Look, alpha is at a particular instant constant for a particular instant.
Yes, sir. Yes, sir. It is.
So I can take it outside. What is integral of dmr square?
Oh, that is the moment of inertia.
Yes, I only. So that is a very simple proof that tau is equal to I alpha.
So, but this is not a vector relation, no?
Vector? Yes, it is a vector relation. Alpha
No,
and
what
torque.
is derived?
Yes, alpha and torque, they are the same direction. I have taken this, if alpha was opposite, then this force will also be in opposite direction.
Yes, sir.
Right? So tau and alpha are definitely in the same direction.
I didn't get so what you said.
If alpha were anti-clockwise, what was the direction of your d tau? Going into the plane?
Yes,
Or
sir.
coming
Yes,
out
sir.
of
Yes,
the
sir.
plane? Going into the plane, na? So they are in the same direction. If alpha is in this direction, it is coming out of the plane.
It depends on alpha.
Yes.
So please wait, sir. Let me see this one.
Is it clear to you?
Yes, sir. Please wait, sir. So means tau's direction depends on my choice of alpha. So
Yes. If you do not know torque, it depends on your choice of alpha. If you do not know what is alpha, it depends on the direction of torque. Always they are the same. Just like F equal to m into acceleration. In which
force and
direction?
acceleration are same direction.
Yes. Same thing.
Hmm. So we can consider it as a 1D.
1D means?
না মানে টর্ক আর
Torque.
অ্যাঙ্গুলার অ্যাক্সেলারেশন তো একটা লাইনেই
direction, yes.
যেটা কাজ করছে
Yes, you can consider that. Alright, now there is another interesting thing written in the fourth property. Look, this equation also consists of torques of pseudo forces as well if the observer has an acceleration.
ওকে স্যার
Right? Look, if I ask you what is the torque of a force, you can write it down. But if observer is also moving, right, then what is the torque? Suppose, let us take this example. it is a square plate or rectangular plate, lamina, right? And I am applying a force F here. I am applying a force F here. But this is my x-axis, it is my y-axis, it is my z-axis. If all the sides are A, can you tell me what is the torque of this force F about this point O or about the z-axis?
Oh, sir, it's FA along a negative z-axis.
Yes. So torque about O is F into A along negative z-axis. Yes or no?
So is this a square?
Yes, it is a square plate.
And you have applied force along that line only.
Yes. Everyone, can you understand?
Yes, sir.
The perpendicular distance is A only. But if the observer is at rest, this is the case. Now, suppose my observer is moving with acceleration, say acceleration c. Let us assume this length to be L.
Observer is moving.
Observer is moving with acceleration A. Side
Along
length,
right.
along any
Oh,
direction.
okay.
Along any direction, observer is moving. Suppose observer is moving along this direction with acceleration A, along x-axis suppose. With respect to that observer, now what torque I will write?
I will give a pseudo force.
Yes, but that pseudo force, if I pass that pseudo force through the point O, the torque will be 0. If I pass
Yes.
the pseudo force through this point, the torque will be something different. Then if I pass the pseudo force through this point, the torque will be different.
That means R will differ, you were saying, so.
Yes?
R will differ, direction will differ.
Yes. So at different point of application of pseudo force, look, torque also depends on the point of application. Yes or no?
Yes, sir. Yes, sir.
So at which point you will apply your pseudo force in order to write down the net force?
CM.
Net torque. Always through the center of mass. Remember that. Right? That pseudo force always passes through the center of mass of the body. So this is the center of mass of the body and I will apply a pseudo force MA. So now with respect to that observer, if I ask you what is the torque about point O, what should you write?
So that should be MA root 2 and it will be along positive K cap.
Is it MA root 2 L?
Yes, sir. MA root 2 L.
No, it's not MA root 2 L. Can anyone
Please
else
wait.
try?
Perpendicular distance. No, sir, there's some angle. Sir, please wait. Sir, it's MA root 2L sine 135 degree.
What is perpendicular distance? Is it L by 2 or not? This MA is passing through this line. So what is perpendicular distance from O to that point, to that line? Is it L by 2 or not?
Yes, sir, the perpendicular distance.
Yes. So remember, if your observer or the reference frame is still accelerating, if your observer or reference frame is accelerating, don't only take the torque of real forces, take also the torque of pseudo forces.
Pseudo forces.
Wait for 1 minute.
Yes. But in
So
this
L by 2,
case,
you are saying the this perpendicular distance between the my origin and that line of application. So.
yes. Can you understand this entire discussion?
The pseudo force will act in COM.
Always. Pseudo force will always act through center of mass, and the properties are remaining same. That mass into acceleration, opposite direction will be the pseudo force.
The same properties of pseudo force.
Have you got it?
Yes, sir. Got it, sir. I have got it.
But remember that if in your question they only ask you to find out the torque, I do not mention which observer. Suppose in my question I have mentioned there are different observers. Observer A is inside the train, observer B is inside the car, observer C is on the ground, and I only ask in my question what is the torque about
With
the
respect to
point.
ground.
Always find the torque of the real forces.
Oh, torque means real forces.
Torque means with respect to ground. Always find with respect to ground. Right?
Just torque. Torque means.
Yes. Torque about some point you always find with respect to ground.
Means with real forces.
Only with real forces, yes. Last year, JEE Advance actually asked a question, a very similar question, only they have asked that the torque about the forces about this point, torque of the forces about this point. Now there were two observers in the question, right? So
Yes.
students have done the mistake. All the questions they have solved with the observer which was moving with acceleration, and when they found that option, they have also calculated the torque about that observer taking pseudo force in action. But
Oh,
that was
sir.
not the correct
They
option,
have
right?
taken the complex way.
Yes.
So they have just asked to calculate the torque.
Yes. It was only a
Oh,
multi-correct option was there. Question was there. The option was the torque about point O is this one. Right, so always remember if nothing is mentioned, always think about ground frame. Okay, all right.
This year's question was harder than previous years.
This one, this year, yes, definitely.
Advanced.
Yes, that one question was definitely harder.
Which center made means advanced means which IIT?
I think IIT Bombay made it this paper.
Oh,
All right, is this okay? This slide?
yes, sir.
All right.
Yes, sir.
Now we will try to solve few questions. First, we will try to solve equilibrium of bodies. Equilibrium means, before solving this question, just give me a brief. Just let me give you a brief. What is equilibrium? Equilibrium of bodies means you will need two types of equilibrium here. So you can get two equations. One is translational equilibrium. Translational equilibrium means which is zero.
The rates force is zero.
Translational equilibrium is net force is zero. Another is rotational equilibrium. What do I mean by rotational equilibrium?
Net torque is zero.
Torque is zero. Is that statement correct? That torque is zero.
So please.
Torque about that point.
Torque
Torque
about that.
is-
The net external torque is zero.
But torque cannot be defined unless you define a point. If I give you a force and ask you what is torque, can you find it?
Oh, no, sir.
Torque about some point is only defined. Now about which point I should write
Sir,
it?
it's obviously about center of mass. Sir. Center of mass.
Why center of mass? What's the speciality of center of mass here? We have not studied anything. There is no pseudo force also that you take
Please
that.
wait, sir. So please wait. So the point which will be given in the question, that only will take.
So it depends from question to question.
Yes, sir. Down.
Which point I should take?
Mm.
A very simple answer. When I will say you that answer, you will think that this is a very simple question I am asking you. Rather silly question. Which point I should take?
Say any point.
Why?
So because it depends on the perpendicular distance and the force only.
So for any torque, I can say that any point.
This is what I'm thinking.
If you remember the properties of torques, there we have mentioned that if the net force is zero, torque about any point is same. Do you remember that?
That couple one, so
Yes. So here what is the net force?
here the net force is zero, means we can take about any point in space.
Yes.
Oh,
So torque
no.
about any point is same and any point is zero.
Most that it's independent though. You've
Yes.
shown only that.
Right. About any point torque is zero. About any point.
Oh. So
Understood?
please let me write this.
Now can we solve this question? A simple one. You can do it. Should I do it now?
Exactly. Sir, I'm getting 0. No, wait. Is it 20?
No. Look, try to understand how I am solving these questions, right? Although it is the first question for this equilibrium of bodies, but you can understand it. Look, in the second question first, if I
Sir,
take...
it is 5. Sir, it is 5. Sir, it is 5.
Yes, it is 5 kgs. 5 kg will be the answer. Took the second diagram first. In the second diagram, the body is hinged here. And there is a weight from B. I know how much is that. B is 30 kg, right?
300 Newton.
And there is a weight of the rod itself. Weight of the rod will pass through the center of mass or not?
The rod has mass.
If a rod has no mass, then can this torque be balanced about this point? Right? The rod must have a weight so that the weight of the torque is only balancing the 300 Newton in the second case.
Oh.
Yes or no?
Yes, sir.
So if I say the weight of the rod is say W or mg, how much is this distance? If it is L by 3, given
Yes, it's L by 3.
it is L by 3, and how much is this then?
L by 2 minus L by 3, that's L by 6.
From this diagram, can I calculate what is mg? I will take
Yes.
torque about this point C or this point pivot point P.
Yes, sir.
Torque about P should be 0. What is torque of this 300 Newton about this point P?
So 300 L by 6, and that's into the plane of paper.
That is going inside the plane, into the plane, right? And what is the torque of this mg?
Mg is, it's a mg L by 3.
Mg L by 3, it is coming out of the plane, so I can take it
Yes, it is
minus.
in negative direction. So we can just equate the magnitudes also.
Yes. So from there I can find what is the value of mg, yes or no?
Yes.
Mg is 150 Newton.
Yes,
Yes, sir.
150 Newton.
Now come to the first question, first diagram. The first diagram has all the three masses, it has the same pivot point, same weight 300 Newton.
So it's not the same pivot point.
Acha, pivot point has changed, location has changed. Weight is acting of the rod, and also there is a mass of block A. Suppose this mass of block A is MA. So MAG is acting downward. This is 150 Newton, weight of the rod, and this is 300 Newton. Can I find the distances from here? It is given L by 4.
Yes, sir. L by 4.
So that must be L by 4 also.
Yes, sir.
And how much is this distance? From pivot to this point?
3 by 4.
3 by 4.
3L by 4. Now take torque about the same pivot point P and make it 0. What I will take torque of this MAG into 3L by 4.
Yes, negative direction.
In which direction the torque is? Coming out of the plane?
Out, you can take positive also.
Okay, I have taken positive. 150
Yes.
Newton coming out of the plane, positive.
Yes, 150 L by 4.
And this 300 Newton into L by 4 going into the plane. Yes or no?
Yeah. Yes, sir.
So 300 into L by 4. Can I make them 0? Summation. L by
Yes,
4
sir.
gets cancelled out. So 3 MAG is equal to 150. So MA is equal to 5 kg. That should be the answer of this question.
So we don't need any equation for balancing the means for translational equilibrium.
It's not needed. Why? There
Yes,
is
sir.
also there is a force from this pivot that you do not
The
know.
tension, but that's not contributing to the torque.
Yes, that is not contributing to torque because the torque I am taking about
Force
the
and
same.
line of action are same.
Yes.
Means force and that R vector.
Yes.
And it's not moving, that's why we are saying that torque is 0. So no rotation.
Force, torque is 0, that means no rotation. Yes, it is in equilibrium.
That means we are inferring that torque is 0 because there is no rotation.
Yes, the body is in equilibrium. Somewhere it must be written. A stick AB of mass M is tied at one end to a light string OA. The horizontal force F equal to mg is applied at end B of the stick and remains in equilibrium. Find the angles alpha and beta. Follow it?
So 1 more minute, sir.
Daddy, come back.
Have you got these three forces?
So I have just got a relation, sir.
that is not that difficult. You can understand it like this. Look, if this force is T1, this force is T2, that is equal to mg. This force is also mg. And this angle is beta. Can you say that T1 cos beta is balancing mg? Yes or no?
Yes, sir, obviously.
And T1 sin beta, it's balancing another mg, this one, horizontal mg.
Yes, sir.
So what is beta? If I can divide it, so tan beta is 1.
Yes, so sin beta equal to cos beta.
So beta is equal to 45 degree. That's so beta is equal to 45 degree.
Yes, sir.
What about alpha? This angle is alpha. Can I talk about this point A? Any point I can take, but this point if I take torque about, what is this perpendicular distance of this force of action, this line of action of this force mg, and this distance?
L by 2 sin alpha.
L by 2
L by 2 sin alpha, yes.
sin alpha.
And what is perpendicular distance from this point to this point of application of this mg?
So, sir, can you please repeat from the last line, sir?
I have to find torque about this point A. So I have to find distance, perpendicular distance from A to
the line of action.
mg. Yes, line of action of this mg and this mg.
Okay, sir.
So this is L by 2. So that must be L by 2 sin alpha, and this is L by 2 cos alpha.
That is L cos alpha, no?
It is L cos alpha, yes. It is L cos alpha. So can I take torque about A to be 0, which will give me capital mg into L cos alpha, that should be equal to capital mg into L by 2 sin alpha. Yes or no?
Yes, sir.
Yes, sir.
So
That should be
actually, I
good.
tried to take about CUM, but things didn't work out much good.
About COM also you can take torque. Why not? But about COM you can also take
More
torque.
force. No, not more forces, sir.
Yes, only two forces are there.
It
You will
will,
find the same answer. Tan alpha is
Hmm.
equal to 2 or not? So
Yes, sir,
alpha
tan
is
alpha
equal to
is
tan
2.
inverse 2. That is the answer of this question. It's also a good question. Have you tried this?
I tried but couldn't solve, sir.
Sir, can you please give 2 minutes to get this question?
Yes, you can understand this question. It says a uniform right angle triangular lamina is suspended from ceiling with the help of 3 light strings. The plane of the lamina is horizontal and the strings are vertical as shown in figure. In which of the following options tensile forces, means the tensions developed in the strings to the vertices ABC of the laminar arranged in correct order?
Sir,
Yes.
sir, is the answer A?
A greater than B greater than C.
Sir, I am getting either A or D.
How can you say that? Right. What is the logic behind that? That we need to understand.
Sir, can I say what is my logic?
Yes, definitely. Tell me.
Sir, so there are three strings, and as we can see that the triangle is not equilateral. So as per the diagram, so the mass of the triangle is more shifted towards the A and a little bit towards B and the least towards C. So I think the tension should be in that order.
No, it doesn't. It does not matter where the mass is shifted, right? It's not about center of mass. You have to
Okay.
check all the forces also,
So
right?
mass doesn't matter.
Main thing
Mass
is
definitely
the
matters. Mass definitely matters. But here in this way, you cannot say that if the mass is closer to something, its torque will be more, or you cannot say that. And in mostly, it is a planar object, right? If it were a rod only, you could have said that easily. But it is a planar object, then three different forces are acting on it, right? And all the
No,
forces are
I
not
I think the answer should be B.
B. TB greater than TA greater than TC. Okay, let us check what is the answer. Okay, we'll only calculate and you will then find what is the answer. Whether it is A or B, what is the answer that you will calculate. Suppose these are the three tension forces that I have drawn,
TA, TB, TC.
and there is definitely one force which is the weight.
I think the answer was wrong.
Yes,
only C is left.
Sir, I think B is wrong. I myself said that, but I now think it is wrong.
all right. So now, what are the different forces? Let us check. These sides are A, B, and C. Suppose this center of mass of the plate is O. TA acting here, TB is acting here, and TC is acting here. Look, the plate is in equilibrium. So definitely from force equation, you can write that TA plus TB plus TC equal to 0. Yes or no? Plus TC equal to mg.
Yes, sir.
Yes,
Right.
sir.
And as the torque is also 0, now about which point I will take the torque?
That's the main question. Sir, I think you should take it about
Sir, I
any
think it should be
vertex.
taken about
I think
the
about
vertex.
any vertex will be better. Sir, about B. About B.
Look, here always remember one thing. Whenever you will take a torque,
We have to keep the reference point for each
yes,
set.
I
about
think B
which
will
point
be a
I
good
will take
reference
torque.
point. B.
So we can take about any point because it's in equilibrium.
Definitely, it's in equilibrium. We can take torque about any point, but for calculation purpose, to solve the question easily, remember that take torque about the point or axis from where
One of the forces comes.
maximum number of unknown forces pass. Why I have written that? The reason behind that, if most of the unknown forces pass through the
Yes,
point,
it will be 0 about that point.
yes, the torque of all these forces will be 0. So the number of unknowns in your equation will be simplified, will be less.
Hmm.
Here, although all the different forces are acting at different points, but if you think that I will take one axis AB, can I say about this axis AB, the torques are only about of the weight and TC?
Okay.
Sir, if we take about AC,
You can also take torque about AC. In that case, you will find the torque of TB only,
And MG.
mg. And if you take the torque about BC, you will find the torque of TA and mg. In that way, you can calculate all the values of TA, TB, and TC.
Hmm.
Sir, that was good way.
right?
So we can take about an axis also. So.
About an axis also, yes, I have mentioned that about an axis torque is also valid. So let us first try to understand what is the distance of this point O from all the different axes. Can you tell me what is this distance? This distance?
This perpendicular distance.
Yes.
So I'm saying, sir.
Okay, let us draw it here separately, the triangle in a simple plane.
8/3. So I think it should be 8/3.
8 by 3. How we can say that? This is C, this is B, and this is A. This is O. So what is this distance? Suppose this distance is OD or OP. So what is OP? Can I say OP is 1/3 of CB? It is 2:1 ratio. So it is 1/3 of CB. CB is 4. So OP is 4 by 3 or not?
So please repeat this part, sir.
Sir,
In-
what is O?
O
So
is
please
the
repeat this
centroid.
part.
O is the centroid. I have said that for any triangle, it is the property of
Center of mass.
triangle.
Okay, sir.
Yes, that the
So
center
please
of
repeat,
mass.
sir, this part, this triangle part.
Yes, let me repeat. If this is a triangle, any triangle, the centroid lies at 1/3 of the height. It is the property of triangle. You must have studied that,
Yes, sir. Yes, sir.
right? So 1/3
Yes, sir.
of this height is 4 by 3. Similarly, if this is Q, then what is the value of OQ?
It's then 1.
OQ, BA, yes, it is 3 by 3. It is 1. And suppose it is OR. What is OR then?
OR.
Look, this height OR. Actually, I do not need OR. Let us forget about OR. Right? You can calculate it. No problem. If you drop a perpendicular, 1/3 of that you can calculate it. But I can solve my question by taking OP and OQ only. So, if I take torque about AB,
What is 4 by 5?
yes. What is torque about the line AB? Can you tell me torque about line AB? Who is
There
providing
is a
torque?
torque caused due to TC and mg.
So what is torque of TC?
Torque of TC. That's
TC multiplied by what?
the perpendicular distance.
Yes, what is that?
CQ.
Yes. TC multiplied by?
So 4, I think 4.
4. It is the perpendicular distance.
Yes, sir.
This axis from this axis to TC line. What about
Yes,
MG?
sir, yes.
What about MG? What about torque of MG?
So it is that 4/3 into mg.
Yes. Are these two torques in the same direction or an opposite direction?
Opposite direction, or else they would never balance.
So it is minus mg into 4 by 3. Everyone got this one or not?
Yes, sir. Got this, sir. Oh, that part only.
TC
Yes.
is mg by 3. Yes or no?
Yes, sir.
Now if I take torque about BC equal to 0, torque about this line BC, who is providing torque?
Sir, mg and TA.
So what is torque of TA?
Sir, it is TA into 3.
And what is torque of mg?
So it is OQ, that means 1 into mg.
So TA is how much?
TA is mg by 3.
Look, now I do not have to take any torque because I can use this formula. TA plus TB plus TC is equal to
Yes,
mg.
sir.
So if TC is mg by 3, TA is mg by 3, then what is TB?
mg by
That's
3
2
only.
mg by 3.
So basically all the tensions are the same.
Are equal.
Right? Option D is the correct choice.
Sir,
Yes.
sir,
বলো।
স্যার যদি আমরা ভার্টিসিনা নিয়ে আরো একটা কোনো জায়গায় নিই টেনশন আই মিন স্ট্রিং দিয়ে বলতে তাহলে কি সেমই থাকবে টর্কটা?
কোথায়?
স্যার বলছি ধরুন যে কোনো একটা সাইডে একটা জায়গা নিলাম, একটা সাইডে কোনো ভার্টেক্সে না নিয়ে, তাহলে কি টেনশন গুলো সেম থাকবে?
না, কি করে সেম থাকবে? টর্ক তো চেঞ্জ হয়ে যাবে।
না না স্যার, টেনশন তো নিজেকে অ্যাডজাস্ট করে নেবে না, মানে আমি টেনশন কথা বলছি, তবুও কি ইকুয়াল থাকবে টেনশন গুলো?
না না, সেম কি করে থাকবে? টেনশন তুমি এক্ষুনি তো বলছো তুমি টেনশন অ্যাডজাস্ট করে নেবে নিজেকে, মানে ওর ভ্যালু বেড়ে যাবে বা কমে যাবে।
স্যার কোন কেসের এটা?
ও বলছে টেনশনটা সিতে না লাগিয়ে যদি আমি এইখানে লাগাই বা অন্য কোনো পয়েন্টে লাগাই।
ওকে।
টেনশন
তিনটে তাহলে কি মিউচুয়ালি ইকুয়াল থাকবে?
না না, ইকুয়াল নাও থাকতে পারে। এটা একটা পার্টিকুলার কেসে এরা ইকুয়াল, আদারওয়াইজ এরা সবসময় ইকুয়াল হতেই হবে এরকম কোনো ব্যাপার নেই।
স্যার,
ওকে স্যার।
বলো।
স্যার বলছি টর্ক তো এফ ইন্টু আর সাইন থিটা, স্যার টিসি আর যে 4 সেন্টিমিটার ওইটা তো পারপেন্ডিকুলার নয়, ওখানে একটা অ্যাঙ্গেল আছে, তাহলে
TC
আপনি এখানে ডাইরেক্ট 4 করে নিলে।
টিসি আর কোনটা বলছো? 4?
হ্যাঁ,
এটা পারপেন্ডিকুলার নয়, এ তো প্লেনের ওপরে লাগছে। তুমি এখনো বুঝতে পারোনি সিচুয়েশনটা।
আচ্ছা ডায়াগ্রামটা এরকম আমি বুঝতে পেরেছি। 3D তে আছে, 3D প্লেন।
হ্যাঁ, প্লেটটাকে হরাইজন্টালি ঝোলানো আছে, তিনটে সিলিং থেকে তিনটে স্ট্রিং ঝুলছে, প্লেটটাকে হরাইজন্টালি ঝোলানো আছে।
হ্যাঁ স্যার বুঝতে পেরেছি। ও
বোঝা গেল এই কোয়েশ্চেন?
Yes, sir.
Okay.
So that PQ you found by that 1/3 so property.
Yes. Now I have given this question: a ladder of mass m, length L, rests
Sir,
on a.
let's try the answer.
Yes, one second. Let me just read the question. Rest on a smooth vertical wall and a rough horizontal floor. The floor is rough, wall is smooth. It makes theta equal to 53 degree with the floor. A person of mass m by 2 stands at a distance L by 4 from the end B. For equilibrium, find the friction force acting at the point B. Yes. Tell me what's your answer?
Is the answer 5 mg by 8?
Okay, let us check. Anyone else got the same answer?
Sir, but sadly my answer is independent of the theta.
Independent of theta. All right. Let us check. For what are the forces acting on the rod at different points? Can you see one force, weight mg, directly comes downward like this?
Yes, mg of the rod, yes.
Mg of the rod. Another force of mg by 2 of the person comes here.
Yes.
One force from the vertical wall, normal reaction force, goes into this line.
N1.
N1. Another normal reaction comes vertically upward from the floor.
Yes, and another friction force towards the left.
And friction force towards the left, definitely. So all these are the different forces acting.
Yes, sir. Hello.
Yes, yes, one second.
Yes.
So let me name those forces first. Suppose this force is N1, let it be N2. It is friction force, it is mg, and it is mg by 2. This angle is theta. So from force equation, what can I say? Force
Sir,
equation,
3 mg by 2 equal to n2.
N2 is equal to 3 mg by 2. Yes, good. Anything else? Friction
Sir,
equal to
and
N1?
n1 is equal to mu
N1
n2.
equal to friction. Oh yes, that's
n1 equal to friction.
Friction equal to N1? That is a static friction, right?
Yes, sir, it is
Yes,
at
sir.
rest only. It has tendency.
So let us take different points and try to find out the torque. Can you tell me which point I will take torque about?
We'll take B, sir. B.
B, yes, because two forces, unknown forces are passing through B. And if you take
Okay.
torque about B, you can easily find N1 in a single equation.
Yes, sir.
Torque about B, right? As I have earlier mentioned, maximum number of force should pass through that point, unknown force. So I can say torque about B is equal to 0. That will give me, what is torque of N1? Can you tell me what is
N1.
torque of N1?
N1 sin theta into L by 2.
L
Oh
by
no,
2?
N1 sin theta into L. Sorry.
L sin theta into n1. L sin theta
Yes.
into n1.
Yes. N1 L sin theta. Good. In which direction this torque of N1 acts? Going into or up the plane?
It's
It's into the plane. That's
Into the
cross.
plane. Going into the plane. Okay, let it be minus if I take into the plane. What is torque of mg about B?
So it's out of the plane.
It's out
And
of the plane. So plus mg into
L by 2 cos theta. L by 2 cos theta.
mg into L by
L
2
by 2 what?
cos theta, yes or no?
Cos theta.
And what is the torque of this mg by 2?
That is mg by 2 into L by 4 into cos theta.
L by 4 cos theta. Can I make it 0?
Yes, sir, you can make it.
And now we can find what is the value of n1. That will be the answer of this question. Right? So I can say that n1 is equal to mg by 2 plus mg by 8. Right? So 4 by 8 plus 1 by 8. 5 by 8. 5 by 8 mg into cos theta by sin theta. Yes or no? Right? So cot theta is equal to 3 by 4 or not? Cot 53 degree is how much? 3 by 4?
So that's that. 3 by 4.
So 5 into 3 is 15 divided by 32 mg. That should be the normal reaction as well as friction force. That is the answer of this question.
Please wait, let me note this down.
Yes, sir. Please move on.
Hey, please wait, sir, please wait. Let me write this.
Yes, right?
Okay.
Cot theta, cot 53.
Cot 53 is 3 by 4, I think, right?
Yes, 3 by 4. 3 by 4. Yes, sir, got it, sir.
Alright. Now this question says a uniform rod mass m length 4L rests in equilibrium, one end on a rough horizontal surface at point B at a distance 3L from end A, it is supported by a fixed smooth roller. The rod just remains in equilibrium. Theta is 30 degree. Find normal force applied by the horizontal surface and coefficient of friction between the rod and the surface.
May I try the answers?
Yes, tell me what's your answer.
The first answer I got mg divided by mu root 3 plus 1. And second answer I got 2 minus root 3.
Alright. Let us check. First, draw the free body diagram of the body. Right, this is the rod. Look, roller, there is a difference between roller and any fixed support. Roller cannot exert a tangential force. Why? Roller means if you apply some tangential force on it, the roller will roll, yes or no?
Yes, sir. Yes, sir.
Right? So roller can only exert a normal force. Roller cannot exert any tangential force. That you should remember. Right?
Means if it tries to exert it itself will roll.
Yes. So that is why roller cannot exert any.
It is smooth also, sir. No question.
It may be smooth or it may not be. It is not mentioned. You cannot apply any tangential force, that you should remember on a roller. So roller can only exert a normal reaction force. Suppose it is N1.
So is friction zero in case of these things?
Even if it is not zero, it will be the same situation. Right? It is not always zero.
Okay.
Here at this point, if you think about the forces, one force is from the ground, like this.
Friction is there towards right.
Friction is acting here in this direction.
Mg of the body.
And mg of the body will act downward like this. Right?
Yes, sir.
So this point is B, this point is A, and this is mg. This angle is theta. Right? So it just remains in equilibrium. That means if you decrease the angle from 30 degree, it will no longer be in equilibrium, it will slide down.
So decrease or increase?
Yes, decrease. If you decrease that angle theta, then it will move in this direction.
Yes, towards left.
Yes. So let us assume the normal reactions to be N1, N2, friction to be F. So what equations I will write? First, let us break the components of N1 in order to force balance.
Minus mg plus m2 cos theta equals to 0.
This angle is theta or not? If this angle is theta, this is theta, this is theta.
Yes,
So
that one is theta, yes.
N1 sin theta is equal to F.
N1 sin theta is equals to F, yes.
One equation. And the second equation is N2 plus N1 cos theta is equal to mg.
Yes, sir, yes.
Right? So now if I take torque, about which point I will take?
Sir, you take torque about
Sir, we take about A.
About A only. Yes.
Yes, sir. Because two unknowns are passing through it.
Yes. So torque about A is 0. What can I say torque about A? What is the torque of mg?
mg cos theta.
mg cos
cos
theta is
theta
equal
into
to N1.
mg. L by 2 cos theta into mg.
Yes. So mg into L by 2 cos theta. And what about the torque of N1?
N1 into 3L.
Sir, 2L cos theta.
Acha, this length is 4L. So it is
Yes, sir. L by 2 because
good, yes. 2L cos theta.
2L.
And that is 3L equal to 0. So can I write N1 is equal to 2 by 3 of mg cos theta?
So please wait, sir. Say N1 will be 3L.
N1 into 3L, this distance is 3L given.
Yes, sir.
Yes,
or no?
sir. Okay.
So N1 if I got, then what is friction force? Friction force equal to N1 sin theta.
Yes, sir.
So that is 2 by 3 into mg cos theta sin theta.
Sin theta cos theta. Sin theta cos theta is sin.
Right?
Sin to theta.
Yes.
mg sin to theta by 3.
Alright, let it be theta. Last I will put the value of theta. Now I have to calculate the normal force applied by the horizontal surface on rod A, means N2. What is N2 then? N2 is mg minus N1 cos theta. Yes or no? So
Oh,
mg
yes.
minus 2 by 3 mg cos square theta. Right?
Yes, sir.
So I can say
Yes,
it is
sir.
mg into 1 minus 2 by 3. Cos of 30 degree is root 3 by 2. So 3 by
So
4.
it is 3 by 4. That.
So half. Mg by 2 or not?
Yes, sir. Yes, sir.
Yes,
So first question is solved. And the next question it says friction force coefficient. Friction force equal to 2/3 mg into sin theta cos theta. Sin theta cos theta is root 3 by 2 or not? 2 sin theta cos theta is root 3 by 2.
Yes, sir.
And that I
mg
can
root 3 by
equate
2
with mu mg, mu n 2. Because it is the maximum friction. Right? Just remains equilibrium means it is the maximum friction. Limiting friction. So it is mu into n2. Now n2 is
So why
mg by 2.
only N2 we will not consider the other normal forces?
What are the other normal force at this point?
Not about that point, but okay, sir.
Yes, friction force only depends on the normal at the point on the surface,
Yes, sir.
not on the other surfaces. So what is the value of mu in this case? Mg by 2 will get cancelled out. Is it 1 by root 3?
Yes, sir.
Yes, sir.
So that is the answer of this question.
So please wait, sir.
Now this question, try it. A rod of mass 2 kg. This rod has a mass 2 kg, length 4 root 2 meter, hinged at the point A. Right? The point 8 is hinged at the point A. Here it is hinged. Okay. With a vertical wall. This is a vertical wall. It is connected with a string at its other end B. And the string is also connected with the same vertical wall at a distance 7 meter from the end A or from the hinge. End B, other block of mass 6 kg is suspended. 6 kg is suspended. Find the tension in the string and what is the reaction force at the hinge. Can you solve it? Just try.
So please wait.
Yes.
Sir,
Bolo.
the tension be 400 by 3 Newton.
No.
For tension, I'm getting such terrible answers.
All right. Look. No problem. That's a bit tough.
Tension I'm getting 400 by 3 newtons, sir.
Yes, sir. I am also getting the same.
Yeah.
All right. Let us just find where you have gone wrong. Right. That is important. Look, what are the different forces that first I will draw? One force is weight 20 Newton here, yes or no?
Yes.
Another force is 60 Newton here. Another force is tension here.
Oh, sir, I forgot to take the component of tension.
Wow.
And now, what is the hinge reaction? Can you tell me in which direction the hinge reaction is acting?
So that I could not find out.
Yes, that no one can tell. So always take two components of hinge reaction. One is vertical, another is horizontal.
Oh no, oh no.
Right?
That's the safe choice.
You should
Yes.
have said this earlier.
So whenever you do not know what is the direction of any force, you take two components.
Yes, sir.
I thought it is
I
like
thought
normal
that
reaction.
Sir, I thought hinge would imply normally in all directions, so it will cancel out so non-normal.
Sir,
No, yes.
I took it like normal reaction.
Hinge can give force in any direction.
sir, may I
Is
tell
it
one thing?
necessary to be in the direction of rod? Means the final one?
Final hinge reaction?
Yes. Yes.
Not necessarily. Not necessarily it is along the
Sir,
rod.
I want to tell one thing.
Yes.
স্যার বলছি যে যদি আমরা এটাকে বি পয়েন্টটাকে হিঞ্জ ধরে নিই তাহলে আমরা রিঅ্যাকশন হিঞ্জের রিঅ্যাকশন ফোর্স ইজিলি বার করতে পারবো না?
বি পয়েন্টে যদি টর্ক ব্যালেন্স করো,
হ্যাঁ স্যার, হ্যাঁ স্যার।
কিন্তু তোমার এই দুটো আননোন থাকবে তো।
স্যার আমরা স্যার ধরে নিচ্ছি একটাই ধরে নিলাম স্যার, তাহলে
সেটা ডিরেকশন দরকার তো, না হলে তুমি ডিসটেন্স
ঠিক আছে ঠিক আছে আমি বুঝেছি।
ডিসটেন্স পাবে না তো। আচ্ছা চলো, সো দিস ইজ টেনশন টি, this is tension T, this is 20 Newton, this is 60 Newton, this is horizontal force H, this is vertical force V. All these are only forces acting on the rod, yes or no?
Yes, sir.
Now, about which point I will take torque?
Obviously A.
Obviously A, yes.
A you have to take.
But if about A I will take torque, no problem of this torque of 20 and 60 Newton. What is the perpendicular distance from A to the tension? That can I find?
That's 4 meters.
It's not 4 root
Sir,
2 meters.
definitely we can calculate.
It is not perpendicular. This is not perpendicular. This is not 90 degree.
So we don't need that. We can just take the component of tension perpendicular to that line.
Component of tension perpendicular to that line.
That's
Yes, but how much is this angle?
So that is, I'm saying that
That definitely calls for
82 degrees. Means 45 plus 37.
82 degree. But how do you know the value of cos 82 degree or sin 82
Sir,
degree?
we just draw a perpendicular line to vertical
Line
from
parallel
B.
to
Then
horizontal.
we find
So
B.
draw a horizontal
Yes.
through B.
All right.
So you can get something.
So if this is a horizontal line, I have got, so basically I will take two components of tension. One is vertical, another is horizontal.
That calls for 37. That angle and that's 45.
Yes.
We mix them up.
Yes.
That's why I
How
was
if
saying
this
82.
is 4 root 2, then 4 root 2 cos 45 degree is also 4 root 2. Right? You can see.
That's 4, no?
It's 4 root 2 meter. It's
That
given.
calls for 4.
4 root 2 cos 45 is 4, no?
4, yes, 4. So if this is 4 meter, this is 4 meter, and out of 7 if 4 is there, so this is 3 meter, and this is also 4 meter, 4 root 2 sin 45 degree. So I can say this angle is 37 degree.
Yes, sir.
Right?
That only I was saying, sir. 45 plus 37, 82.
Yes, yes, good. So what is the component of tension here? Cos 37 degrees 4 by 3t, and sin 37 is 3 by
So 4 by 5, no?
4 by 5, sorry, sir.
4 root 2 sin
And 3 by 5t.
it's much easier.
3 by 5t, yes. One second.
मेरे मेरे এই হালত হয়েছে কি করে
কি?
দেখো সারা গায়ে কাটা
দেবপ্রিয়
চুলকে চুলকে।
Ball.
হ্যাঁ
বল
হাতে চুলকে
আরে বল
নখটা কাটো।
কেমন আছিস?
হ্যাঁ, ভালো আছি, তুই কেমন আছিস?
নখে করেছে আর কিছু না।
তো স্কুলে পরীক্ষা চলছে তো?
হ্যাঁ,
স্যার
আচ্ছা
আছে
দেখো, so this is t cos for 37 and sin 37, and if I take torque about a now, make it 0. What is the torque of 20 Newton about a?
So
that L by
into 2 root 2 sine 45.
So it
L
is
by
2,
2 root 2 into
And
20.
into 2.
20 into 2. What is torque of 60 Newton?
16 to 4.
Okay, all these torques are going into the plane, right? I have taken them positive.
Yes,
Yes,
And
sir.
what is torque of this 4t by 5? Forty by
It's
5
coming
multiplied.
out. It's coming out.
Yes,
It's coming out of the plane now.
yes, that is why I have taken negative.
Okay, sir.
And what is the perpendicular distance?
Sir, I'm saying it's 4.
It's 4. And what is the torque of this 3t by 5?
That's also negative.
Yes,
That's
that's
also
also
4.
negative.
And the perpendicular distance you were asking, so that is
4.
that is also 4.
That is also 4. So if you make it 0, 16 plus 12 is 28t by 5. 28t by 5, yes or no? 16 plus 12. That is equal to 240 plus,
280, no, 280.
yes, plus 40 is 280. So what is the value of tension then?
Oh no, that's 50.
50 Newton.
50 Newton.
sir, where they have gone wrong?
Yes.
Sir, that distance you were saying, so that is perpendicular to the line of action. So
Yes, always. This is line of action. So what is the distance?
Okay.
60 for the same distance for 3t by 5.
yes, sir. Okay, got this part.
Now if tension is say 50 Newton,
Now we can balance only just.
what is the value of V and H? We can find, yes. The value of H you can see, horizontal force, H is equal to 4t by 5, yes or no?
Yes, sir.
So it is 40 Newton. Yes or no?
Yes, sir.
And what is V? V plus 3t by 5 is equal to 80.
V plus 3t by 5 is equal to 80. Yes, sir. So V plus 30 is 80.
So V is equal to 50 Newton.
50 Newton. So magnitude we can get of the.
Yes, so the reaction force is equal to resultant. It is root over of 16 plus 25. It's 41. Right? So 10 root 41 Newton. That is the
Yes,
answer
sir.
of this question.
Yes, sir. That was easy question.
No, I'm saying that is the answer of this question. It is not an easy question, definitely.
Oh, sir, I didn't choose the components, so it would be okay.
Which component? Tension component. Otherwise,
No,
how
that-
you can find out?
This is a mains level question or below that?
Not below that. Definitely, it's not even a mains level question. You can expect this type of question in JEE Advance also.
So, but
Okay.
this looks simple, sir. I just
Sir,
only noticed the
advanced.
components.
Yes. Look, it's not that in advance always the tough questions are asked. Some conceptual questions, easy questions are also asked in advance, right? So look, this question, another thing, another important observation that I want you to note. Can you tell me in which direction this reaction force will act?
Which reaction?
That reaction
sorry.
force, the resultant of V and H.
So I'm saying, sir, that will act in.
Diagonally upwards.
Sir, it's perpendicular to
5 by
tension.
4
Sir,
degree.
perpendicular to tension.
Yes, perpendicular to tension. No.
So please wait. So the angle will be tan inverse 5 by 4.
Yes.
Yes.
No, I'm not talking
Forever.
about the actual angle, but let us try to understand physically. I'm not finding the angle, but physically at which point this force will, the reaction force will pass.
Along the road.
It's not along the rod.
No, it's not along the rod.
Not along the
Definitely
rod.
not along the rod.
So let us just try to understand it from
What
this.
line is the below rod? I said that wrong. It's below rod.
If this is the tension force, can you tell me if I want to get a equivalent force of 20 and 60, 80 Newton, from which point this 80 Newton force I will pass? Suppose there
Sir,
is,
repeat what you were saying.
Please
I'm
repeat.
talking about a point through which if I pass 80 Newton force, it will have the same effect of that 20 and 60 Newton forces individually.
So between B and C.
Between B and C.
Sir, that is.
And you can also easily find out that point.
80 Newton, please repeat, sir. I couldn't get.
I'm saying that if I do not take this 20 and 60 Newton, instead I have only 80 Newton force.
Yes.
So through which point I will pass that 80 Newton force, so that the effect remains unchanged
So between B and C.
between B and C,
Near B.
near B, closer to the point B. Yes.
We can find the ratio.
It's like a center of mass concept, right?
Yes,
If
sir.
you have 2
The
kg
3 by
mass,
4 from B.
yes, 2 kg mass here, 6 kg mass here, then I can say that the net mass, net force I will pass through here, right? Or suppose here.
Thank you, sir.
Yes, have you got it?
Means from C, 3 by 4th part of BC from C.
Yes, we can find this distance.
Yes,
No
find
problem.
that.
So here 80 Newton force is passing. Now I am asking, in this two situation, if these two are forces, then from where the third force, the reaction force will pass. You can note one
Sir,
thing.
opposite to the resultant of these two forces.
Yes. So if I say that their resultant, these two forces are actually, if you extend this line, they will meet here. And definitely you will find that this reaction force will pass through this point only.
Yes, it will be the third side of the triangle in the same sense.
Yes.
Sir, I didn't get this. Means how can you be so sure this is happening?
It will always pass through this point. Why not? If it does not pass through this point,
Sir, why? Sir, why? Sir, I'm asking why.
yes,
that
I'm asking one question. If it does not pass through that point, then what will happen? That try to understand.
Balance হবে না, balance হবে না।
will be violated.
Key balance
Force balance
key
হবে না।
balance হবে না. If it does not pass through this point, then about this point, these two forces will have zero torque. Yes or no? Tension and 80 Newton will have zero torque because they will intersect at this point. But if R force does not pass through that point, there will be a torque of that force R about that point. Yes or no?
Oh yes, sir. That is also a theory.
Yes. But in
Sir, or we can
rotational
say that
equilibrium,
opposite to that resultant.
but
It has
in
to
that
pass through
case, opposite to the resultant you can say, but you can always say parallel force. Opposite to the resultant means this force is not mandatorily passing through that point. Even if the opposite to means, suppose this is
We
R
were saying
vector.
we will shift parallelly, so that we
Yes,
cannot
you can
do.
also shift parallelly any vector,
Yes.
right?
Okay.
But I am saying that if you think about the torque balance, then about any arbitrary point the net torque should be zero. Yes or no?
Yes, sir. About any point.
But if you think about this point where the tension and 80 Newton force intersects, about this point, if R is not passing through that point, there will be an automatic torque of this force R, and the system will no longer be in equilibrium. But if it is in equilibrium, you should
We have
remember,
to pass through that.
yes, all the forces should pass through a common point,
Oh no. Yes, sir.
right? All right. Now this question says a sphere of radius r is supported by a rope attached to the wall. The rope makes 45 degree with respect to the wall. The point where the rope is attached is at a distance 3r by 2 from the point where the sphere touches the wall. Find the minimum coefficient of friction between the wall and the sphere for this equilibrium to be possible. A very good question. If you okay, try this question. Okay. So first let us calculate from where the tension force will pass. If this is 45 degree, this is 90 degree, then this horizontal distance will also be 3r by 2 or not? Tension
Sir,
will...
sir, I'm writing the question. Sir, can you please wait 1 more minute?
Yes. Is this okay? Tension is acting at this point.
Yes, sir.
Yeah. Okay. That's okay.
So if I join this line, yes, this is the diameter. So tension is acting here. Now I will draw the forces. What are the different forces? Let me check. One is the one force norm. The mg force will act along this line.
Yes, sir.
Yeah.
Tension
Yes,
is
sir.
acting along this line.
Tension.
Normal reaction from that wall will act along this line.
And friction upwards, I think.
Friction is upward.
You can control in any direction at
Yes,
first.
any direction you can check. No problem.
Oh, nice.
Friction, normal, mg and tension. Are these only our forces?
So I think so.
I'm not getting any others.
So, suppose this point is O, the center, this point is P, and this point is Q. If I take, look, about which point I should take torque? If I take...
About which, you should take about P, I think. P.
You can take torque about P or Q, but if I have to find friction force, then torque about P will not help you, because torque of friction will be automatically 0.
Sir, but I can do it through force equations, but
Yes,
now I have two unknown
definitely
forces,
you can
no?
do it. Also do it.
আরে ইকুয়েশন থেকে তো আমি বের করে নিতে পারবো না
Yeah, you
রিলেশন
can do it, no problem.
Sir, may I tell one thing?
টেনশন তো আননোন,
Yes.
ওটা তো তাহলে বেরিয়ে যাবে।
আরে ফোর্স
Sir, may I
ইকুয়েশন
tell one thing?
বলো বলো।
স্যার বলছি যে এখানে আমরা জানতে পারলাম কি করে, মানে আপনি যে ও এর এই পাশে টেনশন নিলেন, আমরা তো এই পাশে নিতে পারতাম।
আরে এটা 45 ডিগ্রি তো, this
ওটা
is
বেশি হবে।
45 degree, this is 90 degree. So if this length is 3r by 2, is not this
that would
base,
also be 3r by 2 more than r.
isn't it 3r by 2?
Oh, okay sir, yes sir, yes sir.
So but we studied one day, no, that at the surface it should be normal, so it should pass through the center. Nothing like that.
No.
আমি
It-
স্ক্রিনটাকে অন
It is not always normal. That is some other thing. If you apply some force, impulsive force, then the impulse will act along normal. That is different thing. So let us take torque about Q. Torque about that point Q. Look, torque about that point Q will have no value of torque, normal and tension. Only friction and mg will give torque, yes or no?
About q.
Yes.
Hmm.
So the torque of friction is how much about Q?
That's 3r by 2 times f.
And torque of mg?
mg r by 2.
r by 2.
So you can easily find what is the friction force. Is it mg by 3?
Yes sir. Wow.
Right? Look how easily you can find the friction force. And you need to find the minimum friction coefficient. For that you need also the value of normal reaction force. Because friction is less than or equal to mu into n.
So here I think it's the maximum case, no? Means minimum coefficient বলেছে.
Yes, you can say it is. So in that case, you have to find the normal reaction force n. How do I find normal reaction? You can
So
see.
through FBD.
Yes. Now the force equation will only do that. Force equation says that friction is equal to friction plus T by root 2 is equal to mg. Yes or no?
Yes, sir.
And also n equal to T by root 2.
Yes.
So if you replace there, n will be 2 mg by 3 or not?
Yes, sir.
So you just put the value here. Mg by 3 less than or equal to mu into n, which is 2 mg by 3. So what is the minimum value of mu?
Oh, so that was an easy question.
So this question says that a uniform wire has been bent in the shape of a semicircle. So it is basically a semicircular wire. The semicircle is suspended about a horizontal axis passing through one of its ends, so that the semicircular wire can swing in vertical plane. Find the angle alpha that the diameter of the semicircle makes with vertical in equilibrium.
Sir,
Yes.
See, is it like a pendulum?
please once tell
Semicircular
the
pendulum?
center of mass of this thing.
Yes, look, the question is that if you have any semicircular object means in front of you, you can just hold one point at the top of that semicircle and you will find that the diameter is definitely not vertical. Can you see that?
Yes, sir.
The diameter makes certain angle with vertical. Now why it is so? Because there the center of mass does not pass through the vertical this point, this original center. Yes or no? Do you know that? The center of
Sir, can you
mass.
please once tell the point of center of mass for
Please
this?
repeat this question, sir.
Yes, okay, no problem. I'll just first let you understand this question, then I will solve it. Okay. Look, the question says that suppose this is a semicircular wire, right? So if you have a semicircular wire, suppose I have cut this section and we have a semicircular wire like this. And if you hold this semicircular wire at this top, will you find this semicircle staying like this?
No, sir. It shifts a bit to right. It will shift a bit
Yes.
to the right side.
Why it will shift? Why this diameter will not be vertical?
This is the center of mass to
Because the
make the
center of
orbital
mass,
equilibrium.
will be at the same
Will be
position.
Yes, because the center of mass is here or not?
Yes.
sir.
So center of mass, their weight is passing through center of mass.
Let's talk about center of mass should be 0.
Not about this point. You think about this point, the point of
Yes, sir.
suspension. If
Yes,
you
sir, then-
take the torque of the mg about point of suspension, it is definitely not 0.
Yes, sir.
No, not at all.
So it cannot stay like this.
Means due to torque, it is being rotated
Yes.
so a bit.
So when it will be in equilibrium, then what can I say? In equilibrium, what
Then
will
torque
happen? In equilibrium, can I say that the center of mass will lie on the same vertical line? This one?
Yes, sir.
Right. So that is the case where you have to find the angle alpha. Right. If I draw the equilibrium condition now, you can
Will
see
it be tan inverse 2 by pi?
tan inverse 2 by pi.
Yes, sir.
Let me check. Now you will find that if I hold it like here, now the body comes like this. In equilibrium, it will be like this. Yes or no?
Yes, it looks a bit tilted type.
Yes. And why it is tilted? Now if you draw a vertical line through the point of suspension,
It will pass through the center of mass.
definitely it will pass through the center of mass.
That's the main thing.
Yes. You have to find this angle alpha.
Oh. So alpha with the vertical, so.
Yes.
Okay.
Now it is not a tough question, I think. Now you can see. A very simple geometry you can apply and find it.
Yes, so I have a question.
Yes.
Sir, you said no, মানে আমরা যদি ওটা সেন্টার মাসটা একটু দূরে রাখি ওই এ থেকে পিভট থেকে তাহলে ওটা একটু টর্কের জন্য এগিয়ে থাকবে কিন্তু এই সিচুয়েশনে ওটা ফ্ল্যাট থাকবে তো একটা প্লেনে
Yes, at this situation it is in equilibrium. If
it
you
will
do
remain
not
flat.
disturb it, it will always remain in this position.
Okay, sir.
So can we calculate the alpha?
Yes, we have to
sir, give us
calculate.
a point.
Sir,
Bolo?
sir, alpha equals to sine inverse 2 by pi.
Sine inverse? Nah.
Answer of sine inverse আসছে।
Nah.
Please wait for
Very simple
That's a deal.
geometry.
so that's the wire, no?
Is it tan inverse 4 by pi?
4 by pi. ভালো করে করো,
Yes.
simple geometry. বলো?
Tan inverse 2 by pi.
Yes.
अरे सर देखे देखे तो
Yes, it is a
inverse
very
2 by
simple geometry. You can see
it is so
if you join this center of mass through the center, what is this height? You remember
perpendicular
this
2r by pi হবে
2 by
2r
pi.
by pi. And what is this? Is the radius r? So what
the
is tan
physics तो
alpha?
पता है क्या ना
What is tan alpha?
Sir, I actually took the r by 2. That's why it was coming 4 by pi.
Tan alpha is equal to 2r by pi divided by r. You have to be careful while solving a question, right? Because in your multi-correct option there will be also a option which is 4r by 4 by pi.
yes
Sir,
Right?
I took r by 2. Don't know. I thought that diameter divided by 2 radius.
Yes,
Don't know
but the
about
paper
me.
setter already knows that he will do that
What he will
mistake. So
think.
that is why he will keep a option tan inverse 4 by pi and he will mark and proceed. Right? So be careful. Yes. So alpha is equal to tan inverse 2 by pi is the answer.